LCD, or liquid crystal displays, are everywhere today. But did you know the technology behind LCDs was discovered over 100 years ago? Cholesterol benzate is a material discovered in 1888 by Friedrich Rentgenser. It changes state from cloudy to clear between 145 degrees and 179 degrees. This state is known as a mesophase, the period between changing from a liquid to a solid. Early liquid crystal displays were small and had to use ambient light to see the change in the LCD. As early LCD devices were introduced to consumers, touchscreen technology was being developed at the Royal Radar Establishment in Malvern, United Kingdom. E.A. Johnson is credited with the first touchscreen technology. In the late 60s, the air traffic controllers used his system to navigate and update information on flights. Touchscreen used small wires to create a bridge circuit. When the operator's finger touched the screen, it interrupted the circuit and created a signal for the computer to receive and process according to its programming. As touchscreens evolved, they eventually made it into a more modern format, the PDA. Apple, Palm, and other companies all competed with touchscreen personal digital devices. There are many different types of touchscreen technologies, each with different advantages and disadvantages. The two most common types of touchscreens are resistive and capacitive, followed by infrared and surface acoustic wave. Resistive touchscreens have a thin conductive top layer separated from a lower conductive layer by small dots. The touch point is created when the top layer makes contact with the lower layer. Resistive touchscreens are the least expensive to manufacture and allow users to use a bare finger, glove finger, or a stylus to activate it. The additional layer of material tends to decrease display quality, however. Capacitive touchscreens use the capacitance of the user's finger to disrupt the current along the display or the projected field in the case of projected capacitive touchscreens. Capacitive touchscreens were the first type of touchscreen ever used, and the newer projective capacitive technology is currently leading the way for touchscreen phones, tablets, and similar devices. While the sensitivity of the projective capacitive touchscreens can be enough that a glove finger can work, it would not work with a typical stylus. Infrared touchscreens use a grid of infrared beams to locate points of contact on the display surface. This allows the user to use virtually any object as the input device. Surface acoustic wave touchscreens emit inaudible sound waves over the surface of the display, which are received by sensors along the edge of the display. When the user touches the screen, some of the sound waves are absorbed. The attenuation level of the received sound wave is used to determine the touch location. There are many current uses of touchscreens. Some of the most common everyday uses include smartphones, tablet computers, ATMs, and PDAs. A lot of vehicles now have touchscreen to control GPS system, stereo, and various other functions. Most stores and restaurants use a touchscreen monitor for customer purchases. You can also rent movies from a kiosk that allow you to pick the movie you want by making selections on the screen. In a way, touchscreens help save lives by keeping patients' vital information at the fingertips of medical professionals. And for the person who has to have everything, there's even a toilet that is controlled by a touchscreen remote. At some point during your day, you will most likely have some kind of interaction with touchscreens. The social impacts of this technology are abundantly clear in daily life. Smartphones, tablets, and in the near future, codenamed Windows 8 are essential products. The touchscreen employs a more natural interface for all types of users, regardless of experience. ATM and Redbox were once the only common kiosks deployed in the world, but now information centers, retail and restaurant establishments, and industry all employ them to save space, provide quality customizable products, and control complex processes. Computer-based training and interactive whiteboards are popular in education systems, businesses, and government agencies, creating a more beneficial experience. Navigation systems, stereos, control systems, photo editing, and even TV news programs utilize a touchscreen. Possibilities seem endless, and the technology will continue to change all around us, affecting our daily lives.
LCD touch technology has also made an impact in several industries. Whether it is government, manufacturing, education, as well as in healthcare, LCD touch technology has increased efficiency, accuracy, and makes jobs and tasks simpler. Two examples of this change can be seen in education and in healthcare. One of the most significant changes in education has been made possible by Apple's iPad. This multi-touch screen tablet computer has been adopted by many classrooms around the country. Apple provides estimates that show more than 3,200 school districts nationwide which have an iPad program that benefits both teachers and students. Apple's iPad makes the learning environment exciting and entertaining while keeping students engaged. Another change in the modern classroom has been the use of interactive whiteboard. This multi-touch technology allows the entire classroom to see the instructor's screen while giving the teacher the ability to control it by touch. One of the great features of this technology for schools is that it is affordable.
With LCD multi-touch technology all around us, it seems as if the future is already here. However, there are some future uses of this technology on the horizon. Researchers at Georgia Tech have developed the use of eyes-free technology by utilizing Braille on the touchscreen for people with visual impairments. Developers based on the technology on the Braille system, and it works by putting 6 dots on the screen in landscape mode, 3 on each side. The user then uses fingers from each hand to press and create the appropriate patterns. Audio feedback is then utilized to confirm the correct input. So far, the researchers have been able to obtain 92% accuracy using an Apple iPhone. There are future uses in the automotive industry as well. Mitsubishi, a Japanese car manufacturer, has announced its conceptual design car interior called the Amiri system. The company hopes to have the design introduced into its vehicles in the next 10 years. The concept features a futuristic dashboard and interior that allows the user to utilize capacitive touch and a cockpit design. The steering wheel has 18 buttons on 2 keypads that allow the driver to control features such as automatic mirror and seat adjustments. Also, there is a personal health monitor that can be used in the event of an emergency. The rear seat of the cockpit design will feature a glasses-free 3D touchscreen. LCD touchscreen technology continues to become an integral and innovative part of our society. Future advances in LCD and touchscreen technology promise to provide commercial solutions for mass production, shipping expenses, while also providing innovative ways to better the user's experience. These potential advances in LCD and touchscreen technology provide us with a promising future that provides a more immersive user experience and a more competitively priced product. One way they've achieved this is by creating the roll-to-roll glass technology. Developed by Corning and Ashi, the glass is a 0.1 millimeter thick, 1/7 of the thickness of traditional LCD glass. 3M eliminated all the materials required for LED edge lighting. Edge lighting is traditionally used in LCDs as backlights. 3M has combined all the technology needed for edge lighting into a simple film put directly on the back of the LCD screen. With all these innovations, the future of LCDs and touchscreens promises to provide a competitive and innovative product for the consumer.